Welcome to ICM-Online problem series in mathematics on real analysis. Problem number 3. Let f be a function from R to R satisfying f of x plus y equals f of x into f of y for every x comma y in R, and limit x tends to 0 f of x equals 1. Which of the following statements are necessarily true? F is strictly increasing, or f is either constant or bounded, or f of Rx equals f of x to the power R for every rational number R, or f of x greater than or equal to 0 for every x in R. Let us discuss the answer. Now option A is false. You can consider the function f of x given by e to the power minus x, which is a decreasing one. Now option B is also false. The last example is sufficient because e to the power minus x is neither constant nor bounded. Now option C is true. Clearly f of nx equals f of x to the power n for every natural number n. Then f of x equals f of nx by n, which is same as f of x by n to the power n, which implies f of x by n equals f of x to the power 1 by n. So f of m by n x equals f of x by n to the power m, which equals f of x to the power m by n, where m and n are natural numbers. Thus, we have proved our claim in the case of positive rational numbers. Now, let us consider the remaining case. Consider f of 0, which is same as f of 0 plus 0, which can be written as f of 0 square by the given property. So f of 0 is either 0 or 1. Now assume that f of 0 equals 0. Then f of x is equal to f of x plus 0, which is same as f of x into f of 0, which equals 0 by our assumption. Now this thing can be done for every x. That means f of x equals 0 for every real number x. That is, f is identically 0. But it is not possible since limit x tends to 0, f of x equals 1. So f of 0 must be 1. Now consider 1 equals f of 0, which is same as f of nx plus minus nx, equals f of nx into f of minus nx, which implies f of minus nx equals 1 upon f of nx, which is same as f of x to the power minus n. Now f of minus m by n x equals f of minus m x to the power 1 by n, and which can be shown to be equal to f of x to the power minus m by n. Thus f of Rx equals f of x to the power r for every rational r. Now option D is true. You can consider f of x as f of 2x by 2, which is same as f of x by 2 square. Being a square, it is non-negative.